Hello guys, we are back with another lead code problem and today is day 20. Let's see the today's problem. And today's problem is Koko eating bananas. It's a highly like question. So let's dive into the question. Koko love to eat bananas and there are n piles of bananas. The ith piles has the piles I bananas. Okay. The ith pile has the some piles I value bananas and the guard have gone and will come back in h hours and Coco decide her banana per hours eating speed of k and h hours she choose some pile of bananas and eat k bananas from that pile. If the pile has less than k banana, she eat all of them instead and will not eat any more bananas during these hours. Coco like to eat slowly but still want to finish eating all bananas before the guard return and return the minimum integer k such that she can eat all of bananas within h hours. So let me explain this question with using this example one. It's better and easy to understand. So there are some piles of bananas you have given and that each and each value denoting how many bananas is present in that pile, and you have given h is equal to 8. It means after the 8 hours guard will come back. And what's your objective? You have to eat all of bananas before the guard come, and or you can say you have to eat all of bananas within this 8 hours, and you have to minimize the uh, eating bananas per hour speed. You have to minimize that. Okay, so let's understand why this output is 4 in that case. Okay, so what's my how can I solve this? So let's see, is it possible if we choose our eating k value is 11, because 11 is the maximum speed we can achieve. In that case you can achieve infinite too, but it's not that so mean. We are going to take only the uh, biggest number of eating bananas per hour. So in that case it's 11. So let's set our k is equal to 11 initially, and see it's is it possible to eat all of bananas. So in that case uh, this is 3, so we can, so let's see, so there is a 3 bananas and our speed is 11, so we can eat all of bananas and still wait for until the hour is complete. So for eating this we need 1 hour, and in that case we also need 1 hour, and in that case we are need 1 more hour, and in that case also need 1 hour. So within a 4 hour we can eat all of them, but it's a minimum k value, I guess no. Let's check out for 10. Is it possible to eat all of them? If let's copy this code guys here to on the code id. Is it better for you here uh, we check for 11. Now we are going to check for 10. For the 10, is it how many are required? Only 1 hour required, because our case is 10 per hour, but here is a 3 bananas only, so I need only 1 hour. I'll eat 3 in the middle of 1 hour, but I'll still wait for until my 1 hour is completed, because there is given a case she eat all of them instead will not eat any more bananas during this hour, so you just keep waiting. So it required 1 hour, 1 hour here also, 1 hour here also, and here is 2 hours required, because its speed is 10 but there is a 11, so it means total hour required is 1 plus 1 plus 1 plus 2. It means 5 hour required to eat all of them, and we have 8 hours. So yeah, that's it. Is it our answer? Maybe it's our answer. Let's check out for 9, and until we are going to check out for 8, 7, 6, 5, 4 and 3. Let's check out for 4, because in that case our answer is 4. Let's check out for 4. So here we required only 1 hour, but here we required 2 hours, because in 1 hour we can eat only 4 bananas. Okay, so in that we are required 2, in that also required 2, but in that we required 3 bananas, because it's 11, and if we divided by 3 we got it, 3 we got, if we divided by 4 we get 3 are required to eat all of them. So 3 here, 2 here, 2 here, 2 here and 1 here. So 3 to 5, 5 to 7, 7 to 8. So yeah, that's pretty much good, because we required 8 hours. Within an 8 hour I'll eat all of them. Let's check out for 3. Is it possible? So for this 3 we required 1 hour here, so I'll just write it here too. Here required 1 hour. There is required 1 hour. For this case we required 2 hour. For this case we required 3 hour, and in that case what we required 4 hours. So it means if I added all of them, so I need 4, 3, 7, 7, 8, 8 to 10. If I set the speed of k is equal to 3, in that case we require 10 hours, but I have only 8 hours to eat all of them, so it's not my answer. So smallest k value is 4 in that case. So how can we approach this question? So it's pretty much straightforward. What I have to do, I have to check it for my highest value to the my lowest value. If I got first time I got invalid case, I'll just return my first my last valid case. In that case my last valid case is this 4, so I have to return this. So if we do we have do linearly. If we do linearly, so let's check what is the value. So that's pile value is 10 power 9. So 10 power 9, it give us a TLE, because if we check out manually 10 power 9 to 1, it's of course is give us TLE, because it's not valid. So can we do better to that? Yeah, we can do better if we use logarithmic. If our solution in logarithmic, if we take out the binary search, so first what I do, I'm going to check for this 11, and my lowest value is going to be 1 in that case. Are you agree with that? What I do, I'll just take the mid of 11, that one 10, 11 plus 1 mid, and I have to search out binary. If I do with binary, it log n, and log n, it's a log n solution is acceptable, so I go with log n solution. So how can I do that? I'll be explaining my thought process within the code, so it's easy to understand then. So I know my L value means lowest value is 1, and my maximum value I'll denote it by R. My maximum value, it's maximum of all of them, in all of them max value. So initially I initialize with 0 and just go with, so let's light it piles. So what I do here, I'll set I have to find out the max value. So max of iterate both of, if R my max, it going to store in that case. So maximum value set in my R. What after that what I do, I have to go, if my L is equal to R, until, let us, if we have only one value, it means, let's see, we have only two, one. If our we have given one, so let's check out it's possible or not. So that thing, if we have only one, if we have only one value, or it may be 3, if my L is equal to R, if this is outer bound, that's the case, we are got first, we got what we got first invalid case. Okay, so let us check. So what I do here, I have to find out first mid. I have to check it, is it possible to for my mid answer. In that case, 11 plus 1, it's giving me 12. 12 divided by 2, it's giving me 6. And what we are going to do, I have to check for this 6, is it possible to make our answer. In that case, for this given input, this 6 is maybe our answer. So if it our answer, so my answer will be lie on this part, 6 to 1. So I'll just again call my binary search to 6. My R is set here, and my 1 is my lower is here. So I'll just find again mid term and again try to compute all the things. So that's why I'll just do. So let me write the code again, guys, first, then I'm explaining all of them. So that's the thing, and I have to check for my answer. I'll make a my check stop function, which going me tell me about, is it possible for this 7, or it's possible for this 5 or not. If it's possible, so I have to check it out for lowest values. If it not possible, so I have go with the maximum values. I'll just move my left pointer to here. So that things, let me just write it all of thing. What I pass it here, I'll just pass it my piles and my mid function, as well as my r's required. If it's true, so I have going for check it out for I'm going to check for my lowest value. So I set my, if it's possible for this 9, so no need to go check it. I have to move my right pointer to here, this it, because my answer may be present in between. So I go with that and write mid -1. Else if not the case, so I have to move my left pointer to one step ahead. So that's it. If I got my L is greater than R, I have to return this L in that case. Let's make our complete our stub function check. After that, then I am explaining little bit more. So it's a bool type. It's a bool type function because it's going to return, is it possible for our answer or not, it give us answer or not. So it's a check function, check taking the 3 parameter. First parameter is pile, let's write it p for our sake of ease, and another is mid, let us rename its ans, is better for us, and let's make h. So what I do, I'll made it taking r variable in which I'm going to store how many are required. First it initialize with 0, how many hours required to eat all of them bananas. Let us, my value is 8, so I have find the all competition. If we take my case speed is 8, so how many are total hour required to eat all of them. If this is less, if given taking piles is greater than 8, so it means it's not possible with that. I have to choose little bit, I have to enhance my case speed in that case. If it's less, so I have to decrease my case speed. So that thing. So let's first find out my taking hours, how many are required if we set the case speed to the my ans. So let's int I is equal to 0, I greater than p dot size and I plus plus. So if my pi is divisible by my ans, it means is it I have to do, let's copy this taking hours because it's a little bit lengthy to write it again and again. So what I do in that case, pi divided by ans. If not, if else the case, what I do, I'll just pi divided by 2 plus 1. I have to add it 1 because let's my piles is 4, so in that if we divide is this, so this is required in 1 hour. I'll eat only 4 bananas, so 2 bananas is left. So if I divide it, so it required 1 more hour to eat 2 bananas in that case. So that's why I'll just add it 1 if it not divisible, if it not it, if ans is not divisor of pi pile size. So it giving me answer. So here I am to check if my taking r, if it's greater than my ans, sorry ans not ans, is h. If it's greater than h, I know it's an invalid case in that case. So in that case I have to return 0, otherwise I have to return 1. So that's my code, guys. Let's run this code, guys, and let me enhance the little bit more size. Okay, it's giving me wrong answer. Why it's giving me wrong answer? I do little bit r it r minus 2. Okay, what is actually give me 3 6 7 8, it giving me 12, it giving me 12, r is equal to l pile mid edge. If check pile size giving me true, if giving me true, I have to decrease my piles and l plus r minus 2, and if this is iterator, oh yeah, I got it, it's ans, sorry for that, bro. So let's run our code, guys, again, and it's accepted. Let's submit our code, guys, and it's accepted. So this question is belonging to binary search on answer. Here what I do, we are do the computation on the answer of, it's a length of the answer, and we are searching, we using binary search on the answer. So that's standard problem, and let me know if you have any doubt in this question. I'll resolve your doubt as soon as possible, and thank you guys for watching this video, and keep grinding.